These are the examples in Lesson 2.5, Properties and Proofs. In this video, you will review equality properties you learned in Algebra 1, learn new equality and congruence properties from geometry, and learn how to develop and complete algebraic and geometric proofs. Example 1. In this example, you will learn how to prove each step in solving an equation. Solve the equation for the variable by writing an algebraic proof. That is, justify each step by citing or writing the property you used. Notice how the law of syllogism is used as you write the proof. Now, when we write proofs for algebra, one of the main goals is to help us write proofs in geometry. When you first start learning to write proofs in geometry, it can be pretty challenging at first because it's totally different from anything you've probably experienced before. Algebraic proofs tend to be a little bit simpler or easier, so we start with these. Now you know how to solve an equation like this from Algebra 1, but instead of just solving it line by line, each line that we write for our equation when solving it, we're going to provide some sort of reason. Most of these reasons are going to come from any one of the properties of equality that were gone over in the lesson, reviewed in the lesson from Algebra 1. So to start off with, we have our two-column proof with our T-chart. And the title of the two columns are statements and reasons. Notice that all the statements and all the reasons are numbered and that the numbers correspond. Statements and reason numbers correspond. We also have a formal given statement and a formal proved statement. All of these things are always required in every two-column proof. When we get to geometry proofs, there'll be one more thing required right over here. We'll get to that. So we start with solving this equation, negative 3x plus 2 times 4x minus 1 equal 2 times 4x plus 5. Your first statement, you're always required to write the given statement. I know it seems a little redundant or repetitive to do, but that's part of writing a proof. So you write the given here. Negative 3x plus 2 times 4x minus 1 equals 2 times 4x plus 5. Exactly what appears here goes here. And the reason we can write this statement here is the fact that it was given to us. Now, I won't keep writing to us or to you or whatever. I'll just write given from now on. But just know the reason why we wrote this down, our first step, is because it was given to us. For the rest of the proof, we go step by step, providing reasons, until we get to the very end. Now, the reason why we know we get to the end of a proof is because this will be our last statement. The proved statement, the formal proved statement, should always be the very last statement in your formal two-column proof. So here we go, step at a time. Here we take a look at this equation. We want to get rid of the parentheses first. We use a property to get rid of the parentheses, and that property is called the distributive property of multiplication. So we have negative 3x plus 2 times 4x is 8x. 2 times minus 1 is minus 2 equals, and we can go ahead and do it here. 2 times 4x is 8x. 2 times 5 is plus 10. The reason we could go from this step to this step is that we used the distributor by the distributive property. Of equality. We went from step 1 or statement 1 to statement 2, and here's our reason for doing that. Next, the next thing you would do in solving this equation is you would combine like terms. We discussed in our notes that combining like terms is the same as using the distributive property, but using it in reverse. It's sort of like the converse of the distributive property. So, combining like terms, we have negative 3x plus 8x would be positive 5x minus 2 equals 8x plus 10. The reason we went from statement 2 to statement 3 should go here. It was the distributive property. by the distributive property of equality. Now in parentheses for your notes here, I'm going to write this so you'll remember how we did it. Negative 3x plus 8x. Well, the reason why we use the distributive property is because we factored out an x. So we have negative 3 plus 8x. We factored out the x and just wrote it down once. Well, that's just using the distributive property, but in reverse. Normally we multiply it in. We were just taking it out or factoring it out. And this is how we got 5x from this. Next, we go from statement 3 to statement 4 in solving the equation. We need to either get rid of the 5x or get rid of the 8x. We do this by balancing the equation, and we could either subtract 5x from both sides or we could subtract 8x from both sides. So I'm going to subtract 5x from both sides. So I get negative 2 equals 3x plus 10. So from here to here, we used what property? I said we subtracted from both sides, so it's the subtraction property of equality. And what we did was we subtracted 5x both sides. Everything I'm putting in parentheses here doesn't need to be written in a formal proof. It's just for your notes, unless you want to. 5. Step 5, we have from this step to this step, and now from this step to this step, we need to get rid of the 10, so we subtract 10 from both sides, and we get negative 12 equals 3x. So from this statement to this one, we used what property? The subtraction property again. And we subtracted what from both sides? 10. We're almost there. The last step we would perform here is we would divide both sides by 3. So dividing both sides by 3, we would get negative 4 equals x. And look how this is the exact same statement as our proof statement here. That's how we know we're going to be finished after we provide the reason. The reason, again, will be like all of these. It'll be based on what we did on the previous step to this one. We used the division property of equality. And what we did was we divided 3 both sides. This whole thing right here, all of the given proof statements, the T-chart, reasons and statement columns, the numbers, the statements themselves, the reasons themselves, this whole thing is your answer. Example 2. In this example, you will follow the logic of the previous proof by using the law of syllogism. So we're going to actually use example 1's proof. So keep referring back to that. Use the law of syllogism, or using the law of syllogism, write the reasoning for the algebraic proof you wrote in example 1. So, if you noticed as we went through that proof and solved the equation, we were saying if one statement led to the next statement, then that same conclusion statement led to the following statement, and so forth, and that was our law of syllogism. So what they want us to do is just write that out. So they start us off as with the original equation. If negative 3x plus 2 times 4x minus 1 equal 2 times 4x plus 5, then if P, then Q, so this is our first number 1 statement here, then the next line, or statement 2, was negative 3x plus 8x minus 2 equals 8x plus 10. That was our second statement. Period. There's our statement. If P, then Q. Then next we start with the Q. If Q, which is the second statement, we repeat this, negative 3x plus 8x minus 2 equals 8x plus 10, comma, there's our second statement again. Then our third statement. So our third statement was then 5x minus 2 equals 8x plus 10, period. Then we take the conclusion to this one and write it as our hypothesis for our next one. So statement number 3 again. Statement number 3 is if, we use if, it's conditional, 5x minus 2 equals 8x plus 10, comma, then we go on to step 4, statement 4. Then negative 2 equals 3x plus 10, period. Then we do the same thing again with statement 4. Going to statement 5. If negative 2 equal 3x plus 10, then we go to the next statement, number 5. Statement 5 was negative 12 equals 3x, period. And so we have if P, then Q, if Q, then R, if R, then S, if S, then T, and now if T, then U. This will be statement number 5 again. If negative 12 equals 3x, comma, then, and then right here, negative 4 equal x. This is our number 6 statement. Now, we still need to make a conclusion using the law of syllogism. Therefore, if P, then, let's see, this was U, wasn't it? So we said if, therefore, if negative 3x plus 2 times 4x minus 1 equals 2 times 4x plus 5, start with the very beginning statement, then the very last statement, negative 4 equals x. Example 3. Now I think you're ready for a geometric proof. Taking a look at example 3, in this example you'll learn how to write a formal geometric two-column proof. Find 130 degrees equals the measure of angle AOM by using a proof to justify each step you take in solving the problem. Now, if you'll keep reminding yourself when you go through a proof, especially when they get longer like this, that the only 4 things you have to choose from for reasons have to come, they must come from the following 4 things: postulates, definitions, properties, and theorems that have already been proved. Postulates, definitions, properties, and theorems that have already been proved. Now, we haven't had any theorems yet. So right now, all we have to concern ourselves is with postulates, definitions, and properties. So if you'll keep remembering that, it'll narrow down your choices when you start looking at reasons for statements. So here, let's begin. Here we have a formal two-column proof. We're given that the measure of angle AOM is 2x plus 30 degrees. They also drew it here on our diagram. And that the measure of angle COM is x degrees. COM, x degrees. They want us to prove that 130 degrees is equal to the measure of angle AOM, this one right here. So they're asking for the actual measure, numeric measure in degrees of this angle right here. All we know right now it's 2x plus 30. But for every step we take, we have to come up with a reason. So here we begin. Number 1, the measure of angle AOM equals 2x plus 30, semicolon, and then the rest of the given. The measure of angle COM equals x degrees. In other words, everything that's in the given statement, and that was, the reason is because it was given to us. It was given. By the way, given is the only exception to the rule of those 4 things that you choose reasons from, and it'll always be obvious where it comes from. Alright, now that we have the given down, we go to the next step. Angle AOM and angle COM are a what? Well, these 2 angles together, they're adjacent and they form a line. So they are a linear pair. Now, what is the reason that we can say, observe these two angles next to each other and say that they're a linear pair? By the definition of linear pair. So if you looked up the definition of linear pair in your notes, you're going to see something that states that a linear pair of angles are two angles that are adjacent to each other and that create a line around 180 degrees, and that's exactly what they're saying here. So we went from our given information to this new statement, and we made a conclusion. If statement 1, then statement 2, by this reason. Now for statement 3, the measure of angle AOM plus the measure of angle COM equals the measure of angle AOC. Take a look at your diagram, always go back to it. Measure of angle AOM plus the measure of angle COM is equal to the measure of angle AOC, which is the whole thing. Well, that is just, is it a definition, postulate, or theorem? It's a postulate. The angle addition postulate. Because that postulate tells us that we can add angle measures up that are adjacent to each other and get the sum of it would be the measure of the entire angle. So now that we have that, we went from that step, we know that's a linear pair. Now we use the angle addition postulate. Statement number 4. The measure of angle AOM plus the measure of angle COM, so far it's just like statement 3, is equal to blank. Well, what do we know about angle AOC? It's a straight angle, and straight angles always measure 180 degrees. So you would think that would be the definition of maybe straight angle, but it's not, because it's talking about two angles added together that are adjacent and form a line is 180 degrees. Where does that come from? That comes from a postulate we learned. The linear pair postulate. It says that if two angles are a linear pair, then the sum of their measures is 180 degrees. Now, at this point, now that we know that they're a linear pair and we're using the linear pair postulate, we can go ahead and start substituting in values. So our next statement would be substituting in for the measure of angle AOM, which is here in our given statement, and COM, which is also in the given statement. So the next one would be this. The measure of angle AOM was 2x plus 30 degrees plus the measure of angle COM, which is x degrees, equals 180 degrees. Now, when it comes to, this was substitution, we substituted in these values, so this is a property. The substitution property of equality. When it comes to substitution, many times you're going to pull from statements, not necessarily right before that last statement. You may have to come way up here and pull from other statements. In fact, well, this one's pretty clear. You're pulling from statement 3. You're using this statement right here. You've got this angle plus this angle is angle AOC, and you're also pulling from this statement, no, excuse me, the first statement where you have these, you're substituting in values. So statement 1 is used, and also statement 4 is used. So a lot of times you don't have to write this, but it helps if you do. Write the statement numbers that you pulled from to find your conclusion here. So from statement 1 and statement 4, we wrote this statement using the substitution property of equality. Now once you've done that, we are back into solving an algebraic equation again. So dropping the parentheses, we can combine like terms. Combining like terms is which property? That's 3x plus 30 equal 180. So what are combining like terms? Which property is that? That's the distributive property. and we just simply use the previous step. So we distributed by 2x plus x. We pulled out an x, and we had 2 plus 1x, which is 3x. We used it in reverse. 7, step 7, or statement 7. Now we can get rid of the 30, and we get 3x equals 150. So what did we do from this step to this step, or statement? We used the subtraction property. We subtracted 30 from both sides. Now be careful. Substitution and subtraction, do not use sub as an abbreviation. If you want to abbreviate, use SUBST for substitution and SUBTR for subtraction, because if you use sub, no one can tell the difference between, they don't know what you're talking about. They don't know what you're talking about, substitution or subtraction. And then from this step, we have x equals what? 50? How did we go from this statement to this statement? We used the property. Division property of equality. We divided both sides by what? 3? Okay, now back to the geometry. We're trying to prove that 130 equals the measure of angle AOM. And we have the measure of angle AOM equals 2x plus 30, so there's some more work we need to do, more steps, more statements and reasons. Now we have the measure of angle AOM is equal to 2x plus 30 degrees. Where did we get that? Well, we got it from the given. It's in the given again, so right up here. Now this happens to be a statement and reason that's really not required in a proof. I think the reason why they put it here is to remind you of what we were doing. But normally, it's not there. And you would have to come back up here and use this again to go on to this statement. But anyway, it helped us out a little bit. Now that we have that, statement 10 is the measure of angle AOM is equal to what? Well, we've got the measure of angle AOM is 2x plus 30. What else do we know about the measure of angle AOM? The measure of angle AOM, we know x, so we can substitute in for that 2 times x, which was 50, plus 30 degrees. When we multiply this and add it, we're using the order of operations, but we'll get to that in a minute. This was substitution. We substituted in the x. So substitution, property of equality. And which steps did we use, or statements did we use? We used statement 9, because we had to use this, but we also used statement 8, because we had to use the 50. So you might want to write this. 8 and 9. Numbers 8 and 9. Now that we have that, we go down to the next one. The measure of angle AOM equals, it's the same thing as we had in number 10. So what are they asking us or implying for us to do? Well, we need to go ahead and combine all this. Multiply and add. When you multiply, add, subtract, divide, or any combination thereof, you're using the order of operations. So 2 times 50 is 100. 100 times 30 is 130 degrees. So what did we do from this statement to this statement? We used the order of operations, and that is a property. Finally, we're almost there. We have 130 degrees equals the measure of angle AOM is what we need. Here we have the measure of angle AOM equal 130 degrees. So obviously we're going to need this last statement here, so let's write it down. 130 degrees equals the measure of angle AOM. Now how did we go from statement 11 to statement 12? What did we do? Why, we used the symmetric property. The symmetric property of equality in the previous step. And we have completed the proof for example 3. Example 4. What is the name of the property of equality or congruence that justifies going from the first statement to the second statement? Now, basically what we're doing here is we're practicing writing statements and reasons in proofs. This is just focused in. It's a smaller exercise, and they've got 4 parts to it. So what we do is we take the first statement, 2x plus 9 equal 19, and ask ourselves, how did we go from this statement to the second statement, 2x equal 10? So a lot of times what will help if you're having difficulty with it is just cover up, let's say, the right side of both of those equations, equal 19 and equal 10. Cover them up and ask yourself, what's different about the left side of both of those equations? Well, the first one was 2x plus 9, and now we have 2x. What happened? That's right, we subtracted 9. Well, let's see. If we subtract 9 from the right side, does that work? Yes, 19 minus 9 is 10. So what we did was we subtracted 9 from both sides. So we used the subtraction property of equality. That's your answer right there. That's all you need. But for your notes, you might want to write we subtracted 9 both sides. Part B. Angle O is congruent to angle W, and angle W is congruent to angle L. Second statement. Angle O is congruent to angle L. So how did we go from this first statement to concluding this second statement? Notice that O is congruent to W, and then W is being used to set it congruent to angle L. Can you see the property? From O through W to L, we can now say angle O is congruent to angle L by the transitive property. The transitive property of congruence this time. So remember, the transitive is a lot like the law of syllogism. You're going through W to get to L, and you can conclude that O goes to L, or is equivalent to it. C, the measure of angle E is equal to the measure of angle T, and then the second statement's the measure of angle T equal to the measure of angle E. Which property are we using to switch these around? The symmetric property, in this case of equality. Part D, 3x plus 5 when x equals 7, and the second statement is 3 times 7 plus 5. How do we go from this statement here to this one? Notice that they're replacing the x with the 7. Anytime you end up using the word replace, when you're trying to figure out what a statement is showing, then odds are it's going to be substitution. And it is. The substitution property of equality. You substituted x with 7. Example 5. This is kind of the other way around from example 4. In example 5, you'll learn to use given properties to practice writing required statements for proof. So use the given italicized property to complete each statement that follows, and looks like we have 6 of them. Part A, using the multiplication property of equality, it says if negative 13 equals 2/3 x, then blank equals 2x. Again, use the right side of the equation here and here to see what was done. And we know we're using the multiplication property, so we have to multiply something. So 2/3 x times something gives us 2x. Well, the only difference here is that the 3 has disappeared, the denominator 3. So if we multiply 2/3 x with 3, then those 3's will divide out and we'll be left with 2x. So we're actually multiplying by 3. If we multiply the left side by 3, we get negative 39. Is your answer. B, the symmetric property of congruence. That's what we're going to use. If angle ABC is congruent to angle CBD, then angle CBD is congruent to blank. So using the symmetric property, we flip these, and now we get angle CBD is congruent to angle ABC. Part C, the distributive property of equality. Remember, the distributive property can be used in two different ways. You can use it one way and then the converse of it, the reverse. Here we have 7a. If 7a minus 4a equals what? 3 times what? So we have 3 times, well, what they do is they pull out or factor out an a, and we have 7 minus 3 left. 4. 7 minus 4 is 3, and we have an a that has been pulled out. There's our a factor. 7a minus 4a equals 3a. D, the transitive property of equality. Using the transitive property, if the measure of angle N equals the measure of angle P, and the measure of angle R equal the measure of angle P, then the measure of angle N equal what? Now this one's can be a little confusing because we're used to seeing the conclusion here match up with the hypothesis here, and it doesn't. But isn't it true that the measure of angle R equal the measure of angle P is the same as the measure of angle P equals the measure of angle R? By the symmetric property, we can flip those around, and now the transitive property is very clear. If the measure of angle N equals the measure of angle P, and the measure of angle P equals the measure of angle R, then the measure of angle N has to equal the measure of angle R. E, the substitution property of equality. If TU equals 11, and 2 times JK minus TU equals CD, then blank equals CD. So all they have here is this. All of this has been left for us. TU equals, the length of TU is equal to 11. So wherever TU is, it's going to be replaced with 11. You simply write down what you have left. So we have 2 times JK minus, instead of TU, 11 equals CD. So 2 times the length of JK minus 11. Subtraction property, part F of equality. If x plus 3 equals y, then blank equals y minus 3. Again, we want to see, we're using subtraction here, we want to see what we did to one side of the equation to get the other one. Notice that the right side here is y, and the right side over here is y minus 3. So how do we go from here to here? We subtracted 3. Let's see if it works on the left side. X plus 3 minus 3, what do we get? X.